Well, good afternoon, everybody. Thank you very much for joining us this afternoon to have a conversation about quantum computing at AWS and the work that we're doing with enterprise customers all over the world with the service that we offer and some of the technology that we're investing in along the way. My name is Michael Brett. I am a principal specialist for quantum technologies in our advanced compute team. So I'm part of the same team that looks after high performance computing, accelerated compute, variety of other accelerators, but we also look at quantum computing. We consider quantum computing as being part of that portfolio. So CPUs, GPUs, other specialty processors, and quantum is just part of that mix of portfolio. And so we'll talk a little bit more today about exactly what we're doing in quantum computing, the reasons why we're investing in that. We'll also have a talk about what enterprises are doing, how they are taking advantage of the technology that we offer, some of the trends that we're seeing in that market, and then hopefully help you have a think about where your enterprise sits in that overall journey and some of the offerings that we've got available. I'll also be talking about our new offering. We just launched it this week. It's a new program called Quantum Embark. It's designed especially for enterprises that are at the very beginning of their quantum computing journey. And special guest today is Bimal Mehta from Vanguard. Vanguard were the very first customers of the Quantum Embark program. So Bimal will go through their experience in that program in a little bit more detail. So we announced our quantum computing effort exactly 5 years ago at reInvent. It was in 2019. We were thinking about what should AWS do in quantum? How should we be investing on behalf of customers and trying to get an understanding of what customers want in an emerging technology like quantum? There was a lot of interest in it at the time. We were getting questions from our biggest customers about where is quantum computing headed? How should I be thinking about this? How should I invest? And so in 2019 at reInvent, we announced our quantum computing strategy and pre-announced at that event a new service called Amazon Braket, which then went live about 9 months later on the service. And so at the time, as we look back 5 years, what did customers want? What were they telling us that they wanted? Well, first of all, they wanted to understand what quantum could do. Why is it different? What kind of workloads could they run? To get an understanding about this new technology and the potential benefits that it could offer. They also wanted to be able to plan if and when they should engage. This is an emerging technology. What's the return on investment expectation out of this? How much effort should they be putting into it this year or next year or the year after? They also wanted to know how to build internal expertise. Who should they hire? What kind of internal capability do they already have? Who should they be tapping to start to get involved in this journey? And they also wanted to avoid any massive upfront investment. It's an emerging technology. There's a lot of uncertainty. The timelines are very uncertain. And so being able to give our customers some confidence about making a small investment, putting together a small team was really important at the time. And so the strategy that we launched in 2019 included Amazon Braket, a new service for quantum computers. We'll talk about that in some more detail in a second. A professional services team called the Advanced Solutions Lab that would engage in collaborative R&D. We also announced our own hardware effort. So we are building our own quantum computers. We've got a team based at Caltech in Pasadena in California, a special purpose facility where we're building our own quantum computing hardware. If you're interested in more detail on that, I highly encourage you to go check out Peter DeSantis' keynote from last reInvent, so 1 year ago. It's available on YouTube. Spends about 15 minutes at the end of last year's keynote talking about our quantum hardware strategy and where that's headed. And then finally, we're also investing a little bit in quantum networking. Some of the technologies that are involved in quantum communications, quantum security, quantum cryptography. And so that's the overall portfolio of our quantum computing effort. But the centerpiece of that is Amazon Braket. Braket is a service, just like any other service on AWS. EC2 for classical compute, Braket for quantum compute. And Braket is all about critical technology enablement. It's bringing forward new technologies, in this case quantum computing, that allows customers to support the initiatives that they're interested in. So for them to be able to do research and development, to do good science, to understand what this technology is and where it's headed. Also to foster hardware and software development. So to work very closely with hardware partners that are bringing their hardware onto Braket so that we can learn together about what's needed for the future. To bring software partners that can build on top of Braket. application-specific libraries, middleware libraries that can handle error correction and control. And all of that is so that we can learn about this technology together and advance the state of the art in what's possible, and hopefully launch something as quickly as possible that's economically useful to our customers along the way. And so Braket today, it's a cloud service. It's been in general availability for just over 4 years now. And we offer a variety of third-party quantum computers. So we've got access to a range of computers. I'll show you more about those on the next slide. But it's also the landing ground for a future AWS-built quantum computer. We're building that computer on campus at Caltech at the AWS Center for Quantum Computing. And Braket will be the place where that computer eventually lands and becomes available to our customers. And then on the customer side of things, it's for workloads. So it's a learning sandbox. If you're just getting started in quantum computing, if you're a student at university needing to learn this technology, it's a great environment to run your first quantum computing workload. We've got tools that enable you to do that and resources to do it. Experimentation. Most of our customers are researchers. They are researchers at universities and national labs, and they are doing science. So they are doing foundational science into quantum computing technology. They're doing computer science to look at algorithms, to look at the performance characteristics of these devices, to look at techniques for benchmarking, and then experimenting at the application level as well. How could quantum computing be useful in technologies like machine learning or in computational chemistry or a whole range of other things? And eventually future scaling up. We've got a limited number of devices today, but eventually, hey, we're AWS. How are we going to deliver quantum computers in the cloud? How do we get many thousands of these devices into our data centers worldwide so that you as customers can use them in the same way that you use any other device across AWS? So that's what we do today. And the hardware that we've got available on Braket today comes from 4 different providers. So we work with a range of different third-party hardware developers. Right now, we have machines available from IonQ, from Rigetti, from IQM, and QEra. These are different developers of quantum computers, and they're all different. They have different performance characteristics. They behave differently. They've got different pros and cons, and that's part of the appeal of this technology, is being able to get a sense of how it performs over time. So we just launched 2 weeks ago into general availability the latest device from IonQ. It's called the IonQ Forte. This is the highest fidelity chip that we've ever had available on Braket. It's got 36 qubits, very good fidelities. That's now in general availability, which means anyone, anywhere in the world with an AWS account can access this hardware and run workloads on there. In not too long, we'll also be adding the latest device from Rigetti. Rigetti have been one of our hardware partners since the launch of Braket 3 years ago, but their latest device called the Anka 3, an 84-qubit device, that will go up on the Braket in not too long. This lineup will change over time. We fully expect that the hardware environment for quantum computing will continue to evolve, that there'll be new players, that there'll be improvements to these existing players. Our own devices will become available in time, and there'll be a diversity of different chips that are available. So when we're back here again next year, I expect the slide is going to be different again. We're going to have different brands, we're going to have different computers, different capabilities that are available, because this is a rapidly evolving field, and the science is always changing on top of that. In addition to the hardware, we've also got a range of quantum computing simulators. Simulators are really important to developers because they're very low cost, they're scalable, and they allow you to test your algorithms, test different applications, try out different capabilities on a simulation environment at lower cost. Once it's ready, you then deploy to the actual hardware itself. So we've got a variety of different simulators for different applications and different purposes. There's a whole range of backends that we use, including CPUs and GPUs to help drive that. But we just announced this week, one of the launches here at re:Invent was the integration with the NVIDIA CUDA-Q environment, which includes high-performance simulators running on NVIDIA GPUs integrated into Braket. So for the first time, you as a user are able to access the NVIDIA software libraries and then also run those on NVIDIA GPUs all within the Braket environment, test out algorithms before you deploy it to the actual hardware itself. So we're really excited for that new capability. It brings a lot to the partnership with NVIDIA around Quantum. And what we expect to see is a lot more integration between high-performance compute and quantum compute using tools like the QTC203 library over time. So developers have a couple of different ways to access Braket. You can go in through the Braket console environment. We've also got a Python SDK. This is a rich SDK with a lot of different algorithmic primitives, different libraries that you can use. We're integrated into third-party software libraries that allow a lot of extensibility to what you'd like to explore on top of that Braket environment. We also launched last year a new feature to Braket called Braket Direct. So this was announced at reInvent exactly 1 year ago. And this is for the customers that were running the most advanced workloads on Braket. And Braket Direct has 3 distinct features. One is dedicated private access to particular devices. So rather than being an on-demand service, you run your algorithm, you go into the queue, it gets processed, you can reserve a particular device for a particular time to run your workload exclusively. So if you want to take over a device next Tuesday between 3 and 5 p.m., well, the Braket Direct service is available to do that. We also allow you to connect with quantum specialists at the hardware company. So you can talk to the hardware developers directly about their particular machine and any configuration changes that you might want to that machine. And also get advice from them about how best to run your workload through that environment. And finally, the ability to explore experimental capabilities. Over the past year, we've launched a range of experimental capabilities on the machines available on Braket. And these are kind of first look, preview capabilities, different configurations of the machine, different ways that you can access this, so that you can try out the latest features and techniques from the hardware companies before they go into general availability. And so that Braket Direct offering that we announced last year was targeted at the most advanced users of Braket. It was for the scientists and the developers that were running really high-end workloads using the biggest features that we had. And it's been quite popular. We've had a lot of interest in that. But we'll come back to why that wasn't quite enough for the enterprise customers along the way. So, the enterprise customer journey. Braket was launched 4 years ago. During that time, we've had hundreds of customers in enterprise. But what is it that they're doing? What is it that they are actually motivated by to deliver in that Braket environment? And it comes down to 3 motivating factors. Customers are looking to generate intellectual property. They want to run experimental workloads on Braket so that they can come up with new ideas for algorithms. And then as quantum computers become more and more capable, they can keep rerunning them, benchmarking them again, and getting the understanding about which workloads are going to be the most valuable to them as quantum computers become more capable and eventually become performant and are able to outcompete the classical alternatives to that same problem. So customers are motivated to generate intellectual property that is unique to them, where they can run on performant quantum computers in the future. They're also interested in engaging the supply chain, getting an understanding of the hardware landscape, getting an understanding of the software landscape, getting an understanding of the support landscape out there, the algorithm developers that can help them build unique capabilities. There's a lot of interest in quantum. There's a lot of vendors that are building solutions around quantum computing. And so engaging in that supply chain and having conversations and building up a relationship is important to enterprise customers so that they can make sense of that evolving landscape as it changes. And finally, the motivation is to build a workforce. This is a complex new technology. There are challenging aspects to it that are non-intuitive if you're a regular software engineer. And so building up a workforce that understands why this is different, how the algorithms behave differently, the underpinning mathematics, which is very different to classical compute. Having a few people in your organization that understand that and are able to make sense of the news as it comes through is incredibly important to enterprise customers. And so I want to give you 2 quick examples of enterprise customers that we've been working with over the last couple of years that exemplify exactly these motivations over time. One of them is JP Morgan Chase. So working very closely with JP Morgan Chase, they are a great example of the kind of enterprise that is generating intellectual property. They are exploring and developing and publishing new algorithms around quantum compute. One particular study that we did this year was a collaborative R&D effort led by the Advanced Solutions Lab to explore the prospects for quantum speedups on near-term Rydberg atom machines. The Rydberg atom machine is one of the 4 devices that we have on the Braket service today, produced by a company called QEra. So that was a new device that we launched. And so JP Morgan engaged our Advanced Solutions team to look at the potential algorithms, the potential speed up around that, and build intellectual property so that they could potentially exploit that later. And so the result of that work is a paper. It's an academic piece of work. It's IP. It's been published. You can go onto the internet and find this paper and read through it and look at the IP that's been generated. Of course, there's a public side to it, but also some private intellectual property that they'll keep for themselves. But it's a really great example of the kind of work that is happening inside research and development teams at large enterprises today exploring quantum computing. It's deep science, it's understanding the performance characteristics of these devices, and being able to generate IP for the future. Another example of enterprise customers engaged in quantum are Airbus and BMW. We've worked with Airbus and BMW over the past year, again managed by our Advanced Solutions Lab group, to run a global competition to look at 5 challenging problems in the mobility sector that could be solved by quantum computing. So this is a global challenge where we worked with Airbus and BMW to define 5 problems, really characterize the challenging computational complexity of problems in material science, in logistics and supply chain, and a few other things, and then open that up to the world. There's prize money at stake. Airbus and BMW put up 120,000 euros of prize money and said, hey world, if you can solve these 5 challenges using a quantum computer, that would be really, really interesting to us. And in doing so, Airbus and BMW are engaging the supply chain. They are learning about the global potential supply chain for them in algorithmic development and software delivery as they move forward in quantum computing. And the response to this challenge has been phenomenal. We opened the competition in February this year. We've had over 100 entries from software companies and universities around the world. In October, we selected 15 finalists. So there were 15 finalists, 9 were companies, 6 were universities. And those finalists over the last couple of months have executed thousands of hours of experiments on Amazon Braket to characterize the performance of the solutions that will go into that challenge. So there's 5 challenges. There will be 5 winners. And those winners will be announced next week at a quantum industry conference. So watch this space. We're really excited about where this could head and the work that Airbus and BMW have put into it to engage that supply chain, to look at the potential algorithmic performance of new initiatives. And so we'll see where that heads. So 2 really good examples there. So let's take a look now at the overall enterprise capability and readiness journey into quantum. Quantum is an emerging technology. It's got a long way to go. But there are some companies that are more capable than others on this. And so as I click through, I want you to have a think about where your organization sits on this overall journey and the kind of capabilities that you have. So let's take a look, working backwards from the most capable down to those that are just getting started. So the quantum-capable companies are able to do these things. They're able to do collaborative research and development on hardware and software. They're able to adapt quantum algorithms to their specific context and innovate on those algorithms. They're able then to take those algorithms and deploy them onto quantum hardware and to run meaningful experiments on that hardware. They're able to integrate with our high-performance compute capabilities. And they have a dedicated workforce to quantum with a strategy over a long-term time frame, talking 10 years plus, to think about where this technology is headed and how to be smart on it. There are also companies that are engaged in quantum. They're running trials, they're running proofs of concept, they're working with the quantum supply chain to do that work. They've got workflows that are identified and they're reacting to the latest developments. And typically these are companies that will have a working group of subject matter experts with some defined goals over a 3 to 5 year sort of time frame. So they're engaged in this process. They're able to react to the latest developments and new features that we put on Braket, and they're building up that capability over time and will eventually become at that level 3 capable. Level 1 are those companies that are starting to get engaged right now. They have a CTO level mandate. The CTO has said, you need to get smart on quantum computing. I need to be able to eventually have a strategy around this, put together a team so that we can think about where quantum computing will impact our business of the future. And so typically these companies have a few individuals that have some background in quantum computing. Either they did some study at university or they're engaged in this in some way, and they're starting to assemble their team about how to do that. And so that group is the group that we are really interested in right now. The companies at the level 3 end, we're deeply engaged with them. They're running the most advanced features on Braket today. But it's the level 1 companies that we want to get started on quantum compute and give them a pathway to where this is headed in the future. So right at the high end, that's where our Advanced Solution Lab team engages the most. They're doing that collaborative R&D work. They're doing joint science together. They're publishing papers. The engagements are typically 6 to 9 months and doing like deep, innovative work on algorithmic performance. At the level 2, that's where Braket Direct fits in. It's the groups that are using the most advanced features on Braket. They're running reservation windows. They're engaging with the hardware companies directly. They're using the experimental features on Braket over time. But we needed something for those that were just getting started. And that's why this week we've launched the Quantum Embark program. It's a new program from AWS and our Advanced Solutions Lab team, but it's specifically designed for those companies that are getting started. They have a mandate to do something in quantum, but need to build up that capability over time so that they can get to the point where they can run meaningful experiments on Braket. So we're really excited about this. This is a new offering from us. It is designed to fit the profile of those enterprise customers, and so it is a short, sharp, effective engagement from our professional services team. It's 12 weeks. There's no upfront commitment to it beyond that program. And we've designed it in a way so that we can do some quick use case discovery for your particular problem. So in your sector, bringing together a library of previous applications that we've used, recontextualizing it to your specific business. So we'll do some use case discovery together. Then we'll work on training and enablement. We'll build up the skills of some of your teams so that they understand what we can deliver on Braket today, where this is headed in the future, give you the skills to run experiments on your own. And then we'll take a deep dive. We'll look at one specific problem and go work on that together within that program. And by the end of it, you will have a workflow that you've developed on top of Braket. You've characterized the performance of it. You can understand how to benchmark it and rerun it over time as we launch new hardware, and be able to refer back to that as kind of a marquee project of what quantum computing exploration looks like. So we're excited for this. We really wanted to deliver to the biggest customers of AWS actionable outcomes without the hype in quantum computing. A pragmatic approach to getting engaged in quantum computing so that you can understand if and when quantum will impact your business in some way. And so then you can inform senior stakeholders within your business about what the target use cases will look like and how to invest in this across the future. And so our launch customer on this is our good friends at Vanguard, who engaged in the Braket Embark program pre-launch and helped us test that overall engagement and deliver it through it. And so I'll now hand over to Bimal from Vanguard to talk through their experience about working through the Embark program over time. So thank you, Bimal.
Thanks, Mike. All right. So as you heard, right, like Mike said, the reason we went down this journey of Quantum Embark was to understand and differentiate like what is actually quantum computer capable of doing apart from the hype, right? There is a lot of hype around this subject, right? And one of the misconceptions that people have when it comes to quantum computing is that it speeds up things, right? That's a big misconception. Like, yes, it speeds up things, but there is more to it, right? It's not just about speed, it's also about the quality of solutions. So, and I'll just basically briefly talk about our journey at Vanguard of how we started. So we started last year, like that's why we are in the level 1 of this program. we have an internal group that we call as a quantum working group. It's a small group. It's a group of people already working at Vanguard in different domains, be it from the business, be it from the enterprise technology, or be it from machine learning and AI domain. So it's a small group that came together and said, like, proposed a approach, like we need to look at quantum computing. And this idea actually came from our research group, which is Emerging Technology Research Group. That said, like, quantum is one of the areas that's showing rapid growth, right? And that is one thing that we should definitely be looking into and start experimenting with. So that was the motivation behind this. Like, okay, we need to understand what this technology is and what its applicability is within the financial service. So that was step one. What we did as a group is we sat down with vendors like AWS, right? And we came up with a prioritization list of use cases that we are seeing in the industry, especially in the financial services. Like you saw the example of JP Morgan Chase, right? They have been doing this since long. So we came up with our own list of use cases of what we want to do and how we want to do. Right. So we broke this down into three things, right? We created a quantum workforce. This is like people who spend time on understanding what the quantum applications are and what the quantum computers can do for us. Then we also worked a lot on quantum application development prioritization, right? What does that mean? One thing to understand is, like, quantum computing won't solve everything. You cannot push quantum computers where it is not needed, right? There are certain things that classical computers can do very well and will keep doing very well, right? Quantum computers are not here to replace classical computers. That was one of the learning that we also got from this. They are basically going to complement the classical computers. In the future, in the distant future, the scenario will be like quantum computers working with GPUs, right, working with CPUs, and that's exactly what we saw, right? That AWS Braket is doing with NVIDIA, right, through the Q program. So that is one thing. So based on that kind of scenario, right, where in the future you have like this three kind of computers coming together, what are some of the use cases, right, which can work in this kind of hybrid scenario? So that is what we prioritize, like, and we came up with our own list of prioritized areas. That is what I'll share over here. So we saw, like, quantum computing can provide some of the advantages, right, in the long term within financial services in three broad areas. One is the simulation area, one is the optimization area, and one is the machine learning area. So within simulation, right, we did an experiment around Monte Carlo by simulating Monte Carlo pricing for derivatives using a quantum simulator. And today there is a quadratic speedup, right, that Monte Carlo offers when you are using the quantum Monte Carlo algorithm over the traditional Monte Carlo algorithm. But does that mean it's an advantage? No, because if you put 10 different machines together, right, in parallel and do Monte Carlo, you will achieve the same speed up. So it's not an advantage, because if something classical can do in another way, there is no speed up and there is no advantage to it. But yes, there is an advantage in future when we have large number of quantum qubits, especially logical qubits. At that point in time, there is going to be an advantage, right? That was one thing. And then risk calculation and hedging, that was another area, right, that will really benefit from the quantum computing in future. The one experiment, the deep dive that we did with AWS was around portfolio optimization. So we took a subset of that problem, and there were sessions that we also did today showing the demo around that and also doing the deep dive. So it was a simple use case around the Markowitz optimization to see, like, what is the kind of solution does the quantum computer give. So we experimented with variational algorithms. Today, the algorithm that we used was QOA to see, okay, what is the benefit of doing portfolio optimization using a quantum computer. So one thing interesting that we found over here is you may not get a speed up, but if you know how optimization works, right, you always get an approximate solution. It's not never a solution that is close to the global minimum, right, when you're trying to minimize the risk. So optimization as such is an NP-hard problem, right? If you have a lot of variables and you are trying to reach the global minimum, it's impossible to reach the global minimum at times, right? What you get is an approximation of the solution, right? Like then you calculate that approximation ratio, which is around 83%, 89%. So one thing what we found is, like, quantum computers, if they are powerful enough, they can take you very close to the global minimum in the future and help you improve that approximation ratio. So the quality of solution definitely can be improved in the future, given that you have that many logical qubits. At the same time, speed is another thing, right? Today, when we run optimization problems, it takes roughly 8 to 10 hours on a Guru B optimizer, a typical classical one. Can that be reduced? Today, no. The answer is no, right? We cannot reduce the speed. The speed is something that is not possible given the size of quantum computers today. So that is another thing. Then allocations, right, under constraints, this is another area. This is like asset allocation, and where you have got a lot of binary variables and you have got a lot of constraints. How do you do asset allocation under those kind of constraints? That is another area that we are currently experimenting with and seeing if there is an advantage in the future for that one. And then another area that is really emerging is quantum machine learning. So today there is a lot of algorithms, a lot of white papers that you will see in quantum machine learning space. If you had basically looked at IEEE QC, they host an event around quantum computing. A lot of papers were around quantum machine learning. The way quantum machine learnings work is basically they don't use quantum computers as such completely. They use a hybrid approach, right? They use classical computers for parameterization and basically pass those parameters to the quantum computer to find the solution and vice versa. So they use a hybrid approach and they are pretty powerful, and that's one of the things that is still emerging. There is no machine learning algorithm within QML space that has shown an advantage here, but that is a very good area that is emerging, right? And there is a lot of potential if, let's say, the algorithms improve in future and we get a better hardware. So those are some of the use cases that we are experimenting currently at Vanguard, and the one that we did with Embark program was portfolio optimization. And throughout that, we learned like different algorithms that can be applied, like branch and bound, like the variational algorithm, what are the advantages, what are the disadvantages, and how we can prepare for it, right, in the future when we have that kind of hardware available, and to take it from there. So that's about our journey. I'll hand it back to Mike.
Thanks, Bimal. So a really great experience working together with the Vanguard team. They provided the contextual information about the workloads that they needed, the data that was required to do benchmarking and performance characterization. And it was the team from AWS that provided the algorithmic support, the training and enablement, and then a deep dive onto a particular use case there. So it really was a collaborative effort together looking at the potential of quantum computing applications that were relevant to their business. Now, we're looking forward to doing a lot more work together as the computers get more and more capable, rerunning those same applications, getting a better understanding of the trajectory that this technology is on, so that we can be informed users and informed buyers of this technology as it continues to progress. So we're excited to see where this leads. Quantum computing is still day one. It is very, very early days for this technology, but it's advancing rapidly. And the level of engagement that we're getting from our enterprise customers is really heartening, going back to what our expectations were 5 years ago when we first announced our overall quantum technology strategy. So we're excited to see where that leads in the future. So I'll leave you with a couple of thoughts on how to get started with our quantum technologies effort. The first of all is Quantum Embark. We just published a blog earlier this week around the Quantum Embark program. It goes into more detail about what we did with Vanguard and another one of our launch customers, Westpac Bank in Australia, and gives you some more detail about exactly how that program is structured. So if you're interested in that program, please reach out to us. We'd love to hear from you and take you on that journey as well. If you'd just like to use Braket and to get started with that yourself, if you're a developer, if you're interested in running some workloads on real quantum computers, we have a digital course on AWS training and certification. So go to AWS Skill Builder and look up the Braket digital course. Take you maybe 3-4 hours to work through the course. It's free, it's self-paced, it's on demand. You will run some algorithms on real quantum hardware throughout that course. At the end, there's a little quiz. If you score better than 80% on that quiz, you'll be awarded a Amazon Braket Technologies badge. It's not a full certification yet. That will come when we launch the AWS certification for quantum, hopefully sometime in the future. But for now, at least, we've got a digital training badge to mark your journey there. So I encourage you to get started through that courseware. Also, the AWS Quantum Technologies blog, that's where we publish everything about updates to the service, work that we're doing with the hardware team, work that our quantum networking team is doing, customer stories, announcements, examples around this technology. So if you're interested in the journey that we're on around quantum technologies, the blog is the best place to keep in touch with us. And then finally, whole set of example use cases within the Braket software library. We've got a ton of example notebooks in there that take you through foundational courses in quantum computing, running your first algorithms, through to some of the most advanced features. So those are all available on GitHub. They're available for you to click through and to build up your understanding of where this technology is headed in a self-paced kind of way. Finally, we've got a couple more sessions left on quantum technologies this week here at reInvent. If you're really quick, you might be able to get up to the Wynn Hotel and join one of the chalk talks with our colleagues. They're looking at quantum methods for empowering classical workflows in technical computing. Our guests there are the folks from MATLAB, from the MathWorks Corporation, where we've integrated the MATLAB libraries into Braket, and they'll be running through a demo of how exactly that works. And then tomorrow, you can get hands-on with Braket. We've got a workshop running at Wynn. This is a more advanced level workshop to take you through hybrid workloads on Braket. So some of the more advanced features there. So if you want to get hands-on and program some real quantum computers, tomorrow while you're here at reInvent, 3 to 5 p.m. is the place to be there. So that's the end of the presentation. Thank you very much for coming along today and sharing in this conversation with us. Bamal and I will stick around for Q&A for as long as you like. But please reach out if you're interested in quantum. We'd love to have that conversation with you and hopefully take you through that quantum embark process into the future. Thank you very much.